In section 8.4, we're looking at the properties of three more quadrilaterals. We're looking at rhombuses, rectangles, and squares today. So starting out with a rhombus, first special type of parallelogram. A rhombus is a parallelogram with four congruent sides. So it still is a parallelogram, and technically I should have written up here, it is a parallelogram, which means, again, opposite sides are parallel. And it also has four congruent sides. But that's the main thing that sets a rhombus apart. So four congruent sides, I can mark these all with one tick mark here. Oh, a rhombus is also called a diamond, but that's the non-technical term for it. And we have some extra special properties. A rhombus has all of those parallelogram properties plus these two additional ones. Now what do I mean all the parallelogram properties? Remember how a parallelogram has opposite sides congruent, which doesn't really matter here because all the sides are congruent. Opposite angles are still congruent. Of course, opposite sides are still parallel. Consecutive angles are supplementary, and the diagonals still bisect each other. But we have some additional things with rhombuses. First of all, we have perpendicular diagonals. So I'm going to draw on these diagonals here. And what does it mean that they're perpendicular diagonals? It means that they cross at a right angle. So that's a new property. The diagonals of most parallelograms are not right angles, but in a rhombus, those diagonals do meet at a right angle. Also, each diagonal bisects or cuts in half the angles that it's intersecting. So these diagonals are cutting these angles in half. This diagonal is cutting these angles in half. So now I could do one arc here and here, and bisecting this angle. But remember how this entire angle is congruent to this entire angle. Opposite angles are congruent. So this would also get one arc and one arc. So all four of these angles are congruent. This diagonal is bisecting my upper and lower angles, which again, the angles themselves are congruent. So now we're bisecting these angles, so these are congruent. And these would get two arcs as well, because again, the full angles were congruent. So their halves are congruent as well. The cool thing is we form four right triangles that are all congruent by, you could do angle side angle or even side side side. Yeah, so we have like four congruent angles created in a diamond or a rhombus, which is kind of cool. So it's still a parallelogram, but the main thing is that a rhombus has four congruent sides, or all the sides are congruent, and then the diagonals are perpendicular and bisect the angles. Next special parallelogram is a rectangle. Again, a rectangle is a parallelogram with, technically that is part of the definition of a rectangle. Parallelogram with four right angles. So I'm going to mark all four of these as being right angles. And it's still a parallelogram, which means opposite sides are parallel by definition. Opposite sides are congruent. Opposite angles are congruent, but they're all right angles. And diagonals bisect each other. But the cool thing about a rectangle is that for once the diagonals themselves are congruent. That red diagonal I just put in is congruent to this other red diagonal. Now keep in mind with a parallelogram that doesn't happen because a parallelogram, I'm going to use a really non-technical term, is tilty, right? And so you have this tilted diagonal being longer than this one here. Okay, so a parallelogram, that didn't happen. The diagonals were definitely different lengths in the parallelogram because of the tiltiness. But now that we have, sorry about that. But now that we have right angles and we have a rectangle, those diagonals themselves are congruent. And actually the best way to mark this, you know diagonals bisect each other in any parallelogram. So I could do one tick mark here and here in any parallelogram. But normally in a parallelogram I have to do two tick marks here and here. Well, the diagonals themselves were congruent. So these lengths are all the same, right? The whole diagonals are finally congruent. So the halves of the diagonals are also congruent. So that's an extra property of a rectangle. But by definition, a rectangle has four right angles in that parallelogram. And then we have a square, which is a parallelogram with both four congruent sides and four right angles, which really makes it the two things we just talked about, because four congruent sides makes it a what? That would make it a rhombus, right? Four congruent sides is a rhombus. And the four right angles makes it a rectangle. That was the definition of rectangle. So it's kind of cool. A square is both a rhombus and a rectangle and a parallelogram. and a quadrilateral. So it has all of the parallelogram properties. Opposite sides are congruent. Well, that doesn't matter because it's a rhombus and all of the sides are congruent. It has a parallelogram property where opposite angles are congruent, but again, that doesn't even matter because it's a rectangle and all the angles are right angles, so of course opposite angles are congruent. Remember that for sure opposite sides are parallel because it's a parallelogram. And these consecutive angles would add to 180, but that's easy to see because they're 90. And then we have a lot of cool things happening with the diagonals here because it's both a rhombus and a rectangle, and we had special diagonal properties with both. Now, first of all, from that rhombus, we discovered that these diagonals meet at a right angle. They're perpendicular. Also, from the properties of a rhombus, the angles are bisected, meaning these two angles are now congruent, and if it's 90, 90 divided by 2 is 45 degrees. And wouldn't all of these angles be 45 degrees? I mean, these two angles are both 45 because this angle is bisected. I could put that one arc here and here. These are both 45, etc. Which is kind of neat because we're at the point here where all four of these triangles are congruent right triangles that have formed in here, plus they're 45, 45, 90 right triangles, which are those special right triangles that we talked about back in Chapter 7. So now we have the legs being congruent. Oh yeah, because remember how a rectangle, the special property was that the diagonals themselves are congruent? Because we don't have the tiltiness of a parallelogram. So now we also have the fact that since the diagonals are bisected, I'm going to put 2 tick marks here and here, and I don't need a different set of tick marks for this diagonal because the entire length of the diagonals is the same, so their halves are the same. So we have all these isosceles right triangles here, these 45, 45, 90 right triangles that are all congruent. So a square definitely has the most properties because it fits under category of rhombus and rectangle and back to parallelogram. And of course, all of these are quadrilaterals. So let's look at some examples here. One of the first things you're going to have to do is decide whether statements are true for a certain type of parallelogram. So tell whether statements always or sometimes true for rhombus, PQRS. And to figure this out, I think the best thing to do is draw a little sketch. And it doesn't need to be perfect, but you know that a rhombus has 4 congruent sides, right? So I'm just going to mark those and make sure I label it as PQRS going around this rhombus there, PQRS. Would it be always or sometimes true that angle P is congruent to angle R? I'm looking at these two. Hey, they're opposite angles, right? It doesn't even matter that it's a rhombus. The fact that it's at least a parallelogram, opposite angles have to be congruent no matter what. So this is always true. Opposite angles will always be true in a rhombus because it fits under, parallelogram, which said opposite angles have to be congruent. What about here? Is angle P congruent to angle Q? P and Q. Now these are consecutive angles. They add to 180, or they're supplementary for sure, but do they have to be congruent? They'd only be congruent if they were both 90, right? Because they have to add to 180. Well, that happens if this thing would also be a square, and if those are both 90. So probably not. In a rhombus, that generally is not going to happen. But I guess I have to say sometimes because it also might be a square. It might have right angles. So again, the sketch just helped me see where the angles were for sure and make it a little bit clearer. In the next one here, tell whether the statement's always or sometimes true for rectangle ABCD. Now if I sketch out a rectangle, it's a parallelogram with all right angles, right? So a rectangle has to have right angles. But again, it's still a parallelogram, so all of those properties are true. And it's rectangle ABCD, so I'll just go around and label those vertices, A, B, C, D. And always or sometimes true. AB congruent to CD. Here's AB, here's CD. Are those segments always true? Well, they're opposite sides, right? Opposite sides of a rectangle, yes, they're congruent all the time because the rectangle is also a parallelogram and the opposite sides were always congruent. So that's true no matter what. For this one, is side AB congruent to side BC? Well, in this case, these are next to each other. Now, a rectangle does not have all four sides congruent necessarily. So this is a sometimes. They're probably not congruent. They're most likely different lengths. This would only happen if this was a what? Only if it is also a what? Where would the sides be congruent? It already has right angles because it's a rectangle. If these sides are congruent, it means all the sides are congruent, so that would only happen if it's also a square. Actually, up here, wasn't it the same case? Like, if these were right angles, then P would be congruent to Q, which would mean it had opposites, or all sides congruent and all angles congruent. So that's only if it's a square, too. Because it already had the sides congruent, and then if it had right angles, it would be a square. If it is a square. Okay. Ooh, new example. Can you classify the quadrilateral and explain here? So we're giving the best name. Parallelogram would be the most general name, or actually quadrilateral would be then parallelogram, and then we have rhombus, rectangle, square today. So I want to give the best name here. Well, let's see. I have these angles marked with one arc and these with two. I have these two sides marked congruent. Well, wait a second. Both pairs' opposite angles are congruent right now. That means something. Both pairs of opposite angles are marked congruent. So it is a what? This is a parallelogram for sure. In the last section, we said that if we have both pairs of opposite angles congruent, it is a parallelogram. And then what would you know? I mean, I'm looking at these sides. I only have two congruent. But if it's a parallelogram, don't the opposite sides have to be congruent? So then opposite sides are congruent, which is awesome because now I know this is one tick mark, and now I know this is one tick mark. Opposite angles are congruent. All the sides are congruent. When all the sides are congruent in a quadrilateral, it is a rhombus, remember. So that would be the best name for this particular quadrilateral. Because of this reasoning, both pairs of opposite angles are congruent, so it had to be a parallelogram. And then if it is a parallelogram, then the opposite sides are congruent. And all the sides that got one tick mark, they're all congruent. It's a rhombus. All right. What about here? I notice that all the sides are congruent. And we actually were just talking about this particular one. What kind of quadrilateral has all the sides congruent? It is a rhombus. When all the sides are marked with the same set of tick marks there. Remember that opposite sides congruent means it definitely is a parallelogram. So I know it's a parallelogram, but more specifically, a rhombus, seeing all the sides are congruent. And one more example here. You're building a window frame that needs to be a rectangle. Building a window frame that needs to be a rectangle. You know the opposite sides are congruent. Is it for sure a rectangle? Building this window frame. I want it to be a rectangle. Here's what I know. That the opposite sides are congruent. That's what it said. Is it for sure a rectangle? Does opposite sides congruent mean that it's definitely a rectangle? Well, not necessarily. There's no other info to go off of. If I knew these were right angles, then I know it's a rectangle. Opposite sides congruent, I only know that it's a what? I only know when opposite sides are congruent that it's a parallelogram. If that's all I got, it's a parallelogram. And my question to you then, if I want this to be a rectangle, is there something we can measure? Okay, I'm assuming I don't have anything to measure right angles right now because I know if we had right angles it would be a rectangle. Let's say we have a ruler. So is there something we can measure with that ruler that would confirm that it is a rectangle? Remember what we talked about? There was one extra special property about rectangles, and it is something that you can measure with a ruler here. But because a rectangle does not have tiltiness, because of the right angles, do you remember what we discovered about the diagonals? And I can go back here and check that. But in a rectangle, the diagonals themselves are congruent. So what could I do with that ruler to see if this is a rectangle? I could measure the diagonals. And I look at the answers I get for that. I measure both diagonals. I see what I get for those measurements. What do you want? What would show that it is a rectangle? Well, if they are congruent or they are equal measurements, then it is a rectangle. because that property is only true for rectangles. It's only true when you have right angles. So actually it's true for a rectangle and a square, which is categorized as a rectangle. Okay, so talking today about three special parallelograms. We got rectangles, rhombuses, and squares and their special properties.